You have 50 routers and switches across 3 sites. One interface goes down at 2 a.m., and the only way you know is when your boss calls. That was network management before SNMP, Simple Network Management Protocol, the system that lets devices tell you what's happening and lets you fix things without logging into each one individually. Imagine walking from router to router, checking status on every interface manually. SNMP eliminates that by giving you a central network management station, the NMS, and letting every device report to it. The NMS is your monitoring software, running on a server or even just your laptop for smaller networks. Every device that reports to the NMS is called a managed device, and it runs an SNMP agent, software that listens for instructions and sends notifications. Each managed device organizes everything about itself in a database called the Management Information Base, or MIB. Interface status, CPU utilization, temperature, thousands of variables stored as key value pairs. Every variable has a unique address called an object identifier, or OID. OIDs look like long, dot-separated numbers. 1, 0.3, 6, 0.1, 0.2, 0.2, .cdit, 1 to 8 is the OID for interface operational status, and they're organized in a tree structure, just like DNS. The numbers get unwieldy fast, so SNMP applications translate them into readable names. Instead of seeing that long OID string in your dashboard, you see CPU utilization. The NMS reads device data using GET messages. It sends a GET request to an agent on UDP port 161, specifying which OID it wants. The agent looks up the value in its MIB and sends a response message back to the NMS. You can automate this. Have your NMS poll every device every 60 seconds for interface status, traffic rates, memory usage. That's how you get real-time dashboards and historical graphs without touching any CLI. But SNMP isn't just for reading. It's also for writing. A set message from the NMS tells a device to change something in its MIB, like bringing an interface up or down. That's equivalent to running no shutdown on a router from your monitoring station. You can also use set messages to change host names, update DNS settings across all routers at once, or even trigger a system reboot. Some OIDs are read-only though. You can't set the internal temperature of a device, for instance. The third operation is notification. The device tells you something happened without being asked. When an interface goes down or temperature spikes past a threshold, the agent sends a trap message to the NMS on UDP port 162. Traps are fire and forget. If the trap gets lost on the network, nobody retries. That's where inform messages come in. They work exactly like traps, but the NMS acknowledges receipt with a response. If the managed device doesn't get that acknowledgement, it retransmits the inform. For anything important, an interface going down is definitely something you need to know about. Informs are the way to go. Let's pin down where things live and what ports they use, because this is exam territory. The NMS runs the SNMP manager. That's what sends GET and SET messages to devices, and listens for trap/inform notifications on UDP port 162. Each managed device runs the SNMP agent. It listens for GET and SET messages on UDP port 161. The application is the GUI you interact with, like PRTG Network Monitor. It translates OIDs into human-readable labels and gives you charts. Remember, agent listens on 161. Manager receives traps on 162. GET is straightforward. Ask for specific OIDs, get their values back. But what if you don't know which OIDs exist? GET next. asks for the next OID in the tree after a given one, letting you walk through all available data without knowing it ahead of time. GetBulk takes this further. Instead of walking one at a time, you can request an entire range in a single message. GetBulk is much faster for pulling large data sets, like all interface statistics across every port on a switch. SNMP v1 and SNMP v2c use community strings for security, essentially plain text passwords. There are two types: read-only, which only allows get operations, and read-write, which also allows set. The problem is clear. Community strings are sent in clear text across the network, so anyone who can sniff traffic reads your SNMP password. On Cisco iOS, you configure them with SNMP-server community, followed by the string and either RO or RW. You can also restrict which NMS addresses are allowed with an ACL, but the fundamental security problem remains. SNMP v3 fixes everything v1 and v2c got wrong. Instead of community strings, it uses a user-based security model with groups. You create a group that defines the security level, then assign users to it. There are 3 levels. No auth, no priv means no authentication and no encryption, basically the same as v1. Auth no priv adds hash-based authentication, username and password verified, with SHA or MD5, so passwords aren't sent in clear text. Auth priv adds encryption on top. AES encrypts the message payload, so even if someone intercepts it, they can't read what's inside. Auth priv is the only level you should use in production networks, and CCNA expects you to know these 3 levels. SNMP is the backbone of network monitoring and management. Get messages, pull device data. Set messages, make configuration changes remotely. Traps and informs alert you to events in real time. SNMP-v3 with AuthPriv gives you authenticated, encrypted management, the kind of security a modern network needs. And it all runs on 2 UDP ports, 161 for the agent and 162 for traps.